Hello, now here we are going to see the world of metals and nonmetals, and here you are going to see that whatever confusion you are getting in terms of electronic configurations about the properties of the metals and nonmetals, and what is the corrosion, how to prevent the corrosions. These are the very important aspects for the examination point of view, so that we are going to discuss in this. So first we have physical properties of the metal. So that physical properties, so here if you see that most of the metals are solid at the room temperature. But what is exceptional here? Mercury, that is the liquid at room temperatures. And gallium and cesium, this is going to be melt at room temperature. Even if you keep not room temperature, at body temperature, even if you keep in the palm, it's going to melt. So these are the exceptions. Okay. So that is most important for the assumption point of view. Next, we have physical properties. So metallic lessures due to the shining surface of the metals. Malleability. So you can beat into the thin sheet. So gold and silver are the most malleable. Then next is the ductility. Ductility means you can draw the thin sheet of this. So by the help of 1 gram of the gold, you can draw the length of 2 kilometer wire. Next, you have conductivity of heat. So it is very good conductor of heat, okay, and it has very high melting point. So like we have silver and copper, but exceptional is lead and mercury are the poor conductor. So exceptionals also we have to always keep in mind. So maximum times exceptional question they're going to ask. Next, we have conductor of electricity. Yes, it is very good conductor for the electricity also. Okay. So here we have polyvinyl chlorides and plastic coatings is applied on this for the protection purpose. Okay. So this is also important. What we are going to use for the protection. So we have plastic coating or PVC, that is called as polyvinyl chloride. And it is sonorous, or what is the sonority? So it's going to make the sound when you are going to hit, like a olden age school bell. Now we have hardness, it is very hard. Okay. And some alkali metals, lithium, sodium, and potassium are so soft so that you can cut with the knife. So these alkali metals are exceptionals. So these things we have to remember. Exceptionals are very important. Next, we have here seeing that this diagram represents the conductivity of heat of the metal. Okay. Another diagram is represent the that is going to conduct the electricity. So if we keep here any metal here, so once we'll connect the metal between two switch, that two plug here A and B, so finally this bulb should glow if it is the good conductor. So might in the school days we have done this type of the experiment. Okay. So next we have physical properties of the nonmetal. So nonmetals again, if you see that maximum nonmetals are either solid or gas. Exception is what? Bromine, which is the liquid at the room temperature. And metallic lusters, no. Exception is what? Iodine. Iodine having shining surface. Malleability, no. Okay, we can't convert into thin sheet. Ductility, no. We can't convert into the wire. Conductivity of it, no. Conductivity of electricity, no. Exception, graphite. So graphite is the allotropes of the carbon. Okay, and the allotropes is the diamond that you know very well. It is the hardest substance in the nature. Next is the sonority or sonorous, no. Hardness, no, but again, allotropes of the carbon, that is the diamond, which is the hardest natural substance, and it has very high melting and boiling point. Again, we'll have some discussion about carbon and its compounds. There also you see that how diamond structures and graphite structures are going to change from each other. Next, we have chemical properties of metals, how metals are going to react with different substance. So that we are going to see here. First one, when we are going to burn the metal in the air, then what is happening? Already in the chemical reaction we have seen, when we are going to burn the magnesium, it's going to burn with dazzling sounds with white flame. So metal, almost all, but not all, okay, is going to react with oxygen to form the metal oxide. Like here, copper with oxygen, copper oxide, aluminium with oxygen, okay, aluminium oxide we are going to obtain. Another is the amphoteric oxides. Why amphoteric oxide is important? So which is the little different? Such type of the question they're going to ask. So it is the metal oxide that react with acid as well as bases to produce the salt and water. Example is aluminum oxide and zinc oxide. So such type of the oxide is called as amphoteric oxide that react with acid as well as base. So here reaction is also given, okay, that you can see aluminum oxides going to react with HCl, that is the acid, and going to react with sodium hydroxide, that is the base. And what is the product that you need to notice? Next, most metal oxides are insoluble in water, but some of them are going to dissolve, that we call as alkalis. So like here, sodium oxide and potassium oxide, okay. So that is going to form the sodium hydroxide and potassium hydroxide respectively. And later you see that sodium and potassium is going to react with oxygen vigorously. So that's why we keep this one inside the kerosene vial. Since automatic, if will come in contact with air, it will catch fire and it produce a lot of heat. So at room temperature, elements like metal, magnesium, aluminum, zinc, and lead are covered with thin layer of oxide to prevent the oxidation. And whereas gold and silver, AU is the gold, Ag is the silver, do not react, okay, even at high temperature. Next, what is the anodizing? It is also important questions. So it is the process where thick oxide layer of aluminum is going to form. So that pure aluminum is going to act as the anode and it has electrolysis with the dilute H2SO4. So finally, it is the pure aluminum is kept as the anode, okay, on which we are going to provide the thick oxide layer. So it is connected with anode, so its name is given anodizing. So like this, you can correlate to remember many concepts. Next, metal with water. How metal is going to respond with water. So here you'll see that all metals are not going to react with normal cold water. Some will react with hot water. Some metal require the steam. So this is the experimental setup. Here you see that we have glass wool soaked in water and finally metal samples. So when it is being heated, so some metal samples are going to get the steam, some metal samples are going to get the hot water. Finally, they're going to react and finally hydrogen gas is going to evolve here. So this is the reaction that you can see here, metal, but not all. Okay, that always you have to keep in mind. It's going to react with water to form the metal oxides and hydrogen gas is going to evolve. When this metal oxide again further going to react with water, we are going to get the metal hydroxide. So already we have seen that potassium and sodium is going to react violently even with cold water. So here formation of the hydrogen gas will take place that will catch fire immediately. So it is highly exothermic reaction. So here this reaction you can see that here we have heat energy in case of both sodium as well as potassium and it's going to react with even normal cold water. So that is we should be more precautious when we are using the sodium or potassium. Next, we have discussion about other metals. Like calcium react with water. It will react with normal water but less violent, not like a sodium and potassium. And here, in case of calcium, this hydrogen gas is not going to catch the fire, like in case of sodium and potassium we have seen. And this calcium is going to start floating due to this formation of bubbles of the hydrogen gas that will attach with the surface of the calcium. So that's why calcium is going to float. Next, we have magnesium. Magnesium will react with what? Hot water, not with cold water. And it also going to float again due to formation of the hydrogen gas that will stick with the metal. So here if you see that magnesium can react with either hot water or steam of the water to give the magnesium hydroxide, and hydrogen gas is being evolved here. Whereas metals such as aluminum, iron and zinc is going to react only with steam, not with hot water, even with cold water. Only steam is required. So that's why here hydrogen is shown as the gas. It is the steam of the hydrogen that aluminum and iron is going to react. So this reaction we have here. And finally, lead, copper, silver and gold, they are not going to react with water at any situation, whether you are going to pass the steam or you are going to pass the hot water. In both, in any condition, copper, silver, gold, and lead, they are not going to react with water. That we are trying to represent here. Next, metal reaction with water, acids. Earlier we have seen with, first one we have seen metal with air. Next we have seen metal with water. Now we are going to see the metal reaction with acid, how it is going to behave. Okay. So now here if you see that metal is going to react with dilute acids, okay, and it is going to give us salt and hydrogen. So some examples are here. Those are magnesium is going to react with the HCl. We have magnesium chloride. We have aluminum and going to react again with HCl, zinc, iron. So here you can notice that equation should be balanced. Whenever they're asking you to write the equation, after writing the chemical reaction and product part here, you must have to balance the equation. So here later we are going to see about the reactivity series. So magnesium, aluminum, zinc and iron, these are going to decrease in the reactivity. Like magnesium is more reactive in compared to aluminum, aluminum is more in compared to zinc, zinc is more compared to iron in terms of reactivity series. And copper does not going to react with dilute HCl since here it is the low in the reactivity series. So these things are very important here. Next we have when metal is going to react with nitric acids. So nitric acid formula is HNO3. So here when metal is reacting with nitric acid, it's not going to produce the hydrogen gas. So very important here. Why it's not going to produce the hydrogen gas? Since it is the oxidizing agent. Okay, already in the reaction you have seen when we have oxidation reduction, there we have discussion about oxidizing agent. Okay, so it is whatever hydrogen gas is being available here, that is going to be oxidized. Hydrogen will be converted into water and it is going to reduce, that HNO3 is going to reduce in the form of N2O, NO or NO2. So it is very important. Metal react with nitric acid but doesn't evolve the free hydrogen gas. Next here, but some again everywhere whenever we have exceptional, that is very important. Now here if you see that whereas magnesium and manganese is going to react with dilute nitric acids and it's going to produce the hydrogen gas. So in both situation we have hydrogen gas also. So what is the exceptional? Manganese and magnesium. Okay, these two are. Next, we have very important substance. This is called as the aqua. It is also known as the royal water. So this, if you see that what work nitric acid and HCl can't do, so that aqua is going to do. So it is the mixture of the concentrated HCl and concentrated HNO3 in the ratio of 3:1. So ratio is important here. concentrated HCl HNO3, but ratio is 3:1. It has capability to dissolve gold, even platinum also. So it is highly corrosive and fuming liquids. Okay. So that is equalization is very important here. So even if you see that whatever costly clock is available in the market, that is also going to melt with the help of equiligia. Next, we have metal, how it is going to react with solution of the other metal salt. So metal A is going to react with the salt of the metal B, then it is going to form the salt solution of the metal A, and metal B we are going to obtain. So here what we are seeing that high reactive elements going to replace the less reactive elements, and this is also one of the example of displacement reaction. So here if you see the in the experimental setup here for the activity purpose, so here we have copper sulfate solution in this iron nail is here. So iron is more reactive when compared to copper, so it will displace. Whereas here right side we have copper wire and iron sulfate. So copper is the less reactive in compared to iron. So here displacement will not going to occur. Okay, so this is the important factor here. Next here we have right side we have reactivity series. So here most reactive already we have seen sodium potassium is highly reactive. After that it is decreasing in this order calcium magnesium aluminum zinc, and here further iron and lead, and this hydrogen you can take as the reference. Above hydrogen these are the more reactive, and below hydrogen those are the less reactive, like we have copper, silver, gold and mercury are here. So the bottom these are the least reactive here moderately, and upper part is the highly reactive. So this sequence you have to keep in mind. So multiple time you have to write the reaction, that it will be useful for you. Next we have electronic configuration. So here little bit we'll see about how this formation of the compound takes place. So how this metal and non-metals both are going to react. So suppose here right side, and every metal, every elements who are available in the nature, they want to obtain the stable state. So in case of elements, how they will obtain the stable state means their outermost orbit should be fulfilled. So, or in case of higher atomic number, if you see that outermost element having 8 electrons, then those elements are stable. On the basis of here, element atomic numbers and this orbits K, L, M, N are given. So number of electrons in the particular orbit is given as the formula 2 into n square, where n is the number of the orbit. For the k, n equal to 1. So finally here, in case of k, maximum how many electrons can be there? 2. For L, n equals to 2. So 2 to the power is 2 is 4 into 2, 8. Again, n is 3. So 3 square is 9. 9 2 times is 18. Okay. And n is 4. 4 square is 16. 2 times is what? 32. 2, 8, 18, 32. These are the maximum capacity of the particular orbit. Now, when we are writing about this compound, so it is important to remember that valency or atomic number. So in case of sodium, its atomic number is the 11. So sodium is written as 281 electronic configuration, and chlorine, its atomic number is 17. So that is 287. Now here if you see that if sodium will leave one electron, then its outermost shell will have 8 electrons. And when chlorine is going to gain one electron, then its outermost shell will have 8 electrons. It's difficult to lose 7 electrons. So chlorine is not going to lose, it's going to gain. So once sodium will lose, it will form the Na plus, that is the cation. And when chlorine is going to gain one electron, it will form Cl minus, that is what? Anion. So finally, this Na plus and Cl minus, okay, is going to form the compound NaCl. that we are using the daily life, that is the natural salt. Similarly, if you see that magnesium chloride, so for the magnesium, atomic number always important is what? 12. So its electronic configuration is how we are going to arrange 282. So it can lose 2 electrons. And Cl already we have seen it is the atomic number is 17. So it's arranged in the form of 287. So finally again here this magnesium has to lose 2 electrons to get the stable state, and chlorine has to gain 1 electron to get the stable state. So magnesium is going to form the cation Mg2 plus, and chlorine is going to form the anion, that is the Cl minus 1. So finally it is going to become MgCl2. Okay. So like this is important about electronic configuration. These are the noble gas, helium, neon, argon, krypton, xenon, radon, all these things you know about this. This is the metals and some examples of the non-metals, which is used mostly as per this your class standards. These are the useful. Next, we are going to see the properties of ionic compounds, how ionic compounds are more strong, okay, and how in this conductivity will going to takes place. So here transfer of electrons takes place from metal to non-metal, okay. So here it is the activity, this first activity here, this one shows that how its melting and boiling point is high. And this activity shows that how it's going to conduct the electricity. So when salt solution is taken here in this, and here is a graphite rod. So when if you supply this battery supply will be connected here, the sodium chloride will change into the ion form. It will be converted into Na plus and Cl minus. So due to formation of the ions, movement of the ion takes place, and finally this bulb is going to glow in this situation. So this shows that ionic compounds properties. Next we have physical nature here of this ionic compounds. It is the solid, hard, a strong force of attractions are there always whenever we have ionic bonds. So it is very a strong force of attraction, and it is the brittle, and it can break into pieces when pressure is being applied, and melting and boiling point is high, that is shown by this activity. And solubility, so generally it is soluble in water, and it is insoluble in the kerosene, petroleum product, all these things. And conduction of electricity, so this experiment shows this activity is going to represent about conduction of the electricity. So this electricity will be produced here when in which stage? In molten stage. So when electrostatic force of attraction overcome due to heat, so when here heat will be supplied, so due to that it is going to overcome that force of attraction. Finally, that ions will be separated. So due to that, it electricity will be produced, and finally this bulb is going to glow in this activity. Next, very important thing is the occurrence of metal. So far, we have seen that how metals are going to react. Now we are going to see how we are going to obtain the metals, how it is available in the natures. So very important thing is about here minerals. Okay, so what is the minerals? It is elements or compound which occur naturally in the earth crust. That is called as the minerals. And the minerals which is very rich in the percentage of the particular metal, that is called as the ores. So minerals and ores having fine difference. Ores are the rich in the minerals. Now, how we are going to obtain those metals which is available in the nature? Some metals we can utilize directly with the small cleaning. Some metals we can't use directly. For that different process we are going to utilize. So the metals who are highly reactive, for that we have to go through the electrolysis process, and the moderately reactive elements, for that we have to go for the reduction by using carbon, and again which is least reactive, so that is found in the natural state like silver and gold, that we can obtain with a small cleaning process. So here right side this chart is Very important. Okay. So here, so this is going to represent all process. It's going to summarize the all process. First, what we have concentrated ore is here, and this side we have highly reactive. So when it is highly reactive, for that we have to use the electrolysis process for the molten ore. So if it should be molten, then only electrolysis is going to take place, and finally we'll get the pure metal. So in the electrolysis, you know that we have formation of the cathode, anode, and one the which metal you are going to obtain. Later we'll see about this electrolysis refining also. Okay, there it will be much clear how we are going to take that pure metal as the anode, all these things. Okay. So now again we have metals of medium reactivity. Okay, in that case, these metals are available either in the form of carbonate or in form of sulfides. So when it is available in the form of sulfides, then we are going to, it is going under the roasting. And when it is available in the form of carbonates, then it is going in the through the process of calcination. So here only a small difference is that in one we are going to apply the more oxygen, in one we are going to apply the limited oxygen. After calcination or roasting, we are going to obtain the oxide of metals, and from the oxide of the metal it's easy to obtain the metal by reduction process, and finally purification of the metal will takes place. Whereas in case of low reactive metals, it is also available in the sulfide formats. So for that again roasting is going to take place. From that roasting we can obtain the metal directly, and finally refining will take place. So later we'll see that how this electrolysis process or electro refining is going to work. Now here we have some discussion about what is the gangue use. So this is large amount of the soils or sand that is contaminated with ore is called as gauze. Okay. So this is the things that you have to remember. Sometimes maybe one ask questions, okay, about the gangue or gauze. Okay. So this substance which is contaminated with soil and sand, so this large amount, this is called as the gauze here. And extraction of low activity series metal, like we have seen, it is available either in the form of oxide or sulfides. So for that purpose, what we have to do here, we can go for the roasting here. So this oxide of the metals can be reduced only by the heating alone, and it is a example of the ore of the mercury that is known as the kinnaver. Okay, so that you have to keep in mind. Name of the mercury ore is the kinnaver or cinnabar, how you are going to pronounce. So this HGS is going to react with oxygen. So in the presence of heat, it's going to form the oxide and sulfur dioxide. And further, this oxide is being heated, then we'll get the pure metal and oxygen being separated. This copper is available in the form of sulfide. For that again, it is being heated with oxygen, and it is going to produce the copper oxide and sulfur dioxide. Finally, this copper oxide is going to react with the copper sulfide, and finally copper is being separated and sulfur dioxide gas we are going to obtain. So less reactive metal can be obtained directly by the heating itself. So that we have seen that roasting process will take place. So that is the presence of the oxygen. We are going to heat that one. So this is for the low. Next, we are going to see in case of middle active series metals. So that is the moderately reactives. So moderately reactive means it is available in the form of sulfides or carbonates. So first they need to convert into the oxides, and we have seen that from the oxides easily we can obtain the metals. So what is the roastings? So this is used for the sulfide ores, okay, which is converted into oxide by heating in the presence of excess air. So here amount of air is more, so that we have seen in case of less reactive metals also. So whenever we have sulfide ores, roasting we are going to use means we are going to heat in the presence of excess air. So here we have zinc sulfate with oxygen. It is going to give us zinc oxide and sulfur dioxide. Another process is called as calcination. Calcination is used for the carbonates. So carbonates means already here it has oxygen. So that's why it is being heated with the limited air. And finally formation of the oxide takes place and we have carbon dioxide here. Now these obtained metal oxides are reduced to the suitable metal by using reducing agent. What we are going to use as the reducing agent? Carbon or coke, or any reduction process will take place. Even we can utilize the displacement reaction. So like here zinc oxide is being reduced with the help of carbon, or we can use the coke to obtain the zinc, and here carbon monoxide gas is evolved. And manganese oxide is being reduced with the help of aluminium. So finally here you are seeing that displacement takes place. Aluminium displaces the manganese. Okay. And another important concept is the thermit reaction. What is thermit reaction? So this is the one of the kind of displacement reaction which is highly exothermic. And here whatever metal will be produced, that will be in the molten states. So here ferric oxide with reaction with aluminium, it is also used to join the railway tracks or some cracked machine parts. So here if you see in the reaction, so this is the ferric oxides is going to react with aluminium, and finally this aluminium, this iron, whatever we are going to obtain that metal is available in the liquid states. So finally it is used for the joining purpose, and aluminium oxide we are going to obtain here, that is in the form of solid, and again heat is being produced. So finally that heat is going to help in the joining the railway track or some machinery parts. So thermit reaction, this is the also very important concept. So next here if you see that in this diagram some person is trying to join the railway tracks, that is shown here in this diagram. Next we have extraction of the top activity series. First, we have started with low reactive, then high reactive, moderately reactive, and now finally we are seeing the high reactives. So these metals are reduced by the help of what? By the help of electrolytic reduction process. So in the electrolytic reduction process, so here what we have, one anode and cathode terminal is there. The cation of metal is deposited at cathode. So cation, you know that this is the positive ion of cation of metal is deposited where? At the cathode. And whereas anion is where? At anode. So here if you see that we have at cathode, what formation takes place? This is the cation which is available at the cathode is going to react with the electron and finally is getting the stable state sodium. At the anode terminal, this chlorine Cl minus is going to, what is going to happen here? It will lose the electrons. Okay. And finally it's going to become the Cl2. And here we have seen that refining of the metals, further purification for the metals like we have copper, zinc, nickel, silver, and gold. For that, we are using the refining of the metal. So in that refining of metals, again, if you see that in this situation, we have impure metal is made as the anode. Okay, so this impure metal is made as the anode, and a strip of pure metal is where as cathode. So finally, this electrolyte, whatever you are going to use, that is the metal salt itself. For same metal salt, we have to use that same type of the electrolyte of same metal. So when current will pass, this pure metal from the anode, okay. So now this pure metal is where, okay, that is going to dissolve into electrolytes. So now what we have at anode, impure metal is at anode. So now in this from the impurity, what is the pure metal that will going to dissolve where in electrolyte. And finally from the electrolyte, same equivalent pure metal from electrolyte, it is being deposited on the cathode. So first anode to electrolyte, next electrolyte to cathode. Now what is the anode mud? So some insoluble impurities is going to settle here at the bottom of the anode. That is called as the anode mud. And some impurities which is soluble, that will be soluble in the electrolyte itself. Next, we have what is the corrosion and how we can prevent the corrosions. So corrosion always we are saying surrounded by so many metals that is going to be uh, day by day is going to have corrosion process. So here, if you see that some examples are here, that some silver articles, some ornaments is going to become black. Why it is going to black? Since the silver is going to react with sulfur which is available in the air, and it is going to form the coating of the silver sulfides. So that's why the silver ornament is going to become the black. And this copper gains the green coat. Some copper vessels you can see in the home, it will have some greenish coats in some parts is going to become green. So why it is going to become green? It is the copper carbonate. It is going to react with moist carbon dioxide, not the dry, moist carbon dioxide. And once it will react with moist carbon dioxide, it will become greenish and will lose its sign. Okay. And iron acquires a coating of brown flaky substance that we are seeing or normally many places, that is called as the rust when it is exposed to the moist air. So here what you see that moisture is important along with atmosphere in the air, wherever substance we are going to keep, moisture is going to play the role. So here if you see that in this situation, we have three different experiment activity here, A, B, C. So in the A, what is here? We have water, air, everything is there. In that, iron nails rusting takes place. In the second one, what is happening? Only what we have here? This having boiled distilled water. So boiled distilled water is used for what purpose? So boil to remove any dissolved air. Okay, from here, dissolved air is being removed from here. So here if you see that layer of the vial is applied so that this air will not mix with water. So finally here again if you see that water is there but air is not available. So rusting doesn't takes place. In the third situation, if you see that it is here you have dry air, moisture free air. Okay, so what is used here? Drying agent, that is also important here. That is the calcium chloride. So now again here in this case, neither moisture is there, neither air is there. So funny rusting doesn't take place. So from this, what we conclude that for the rusting, moisture along with air is important. That is the essential things for the rusting takes place. Now, okay, how to prevent this? Even rusting takes place. So like we are knowing prevention is better than cure, am I right? So before itself, we have to prevent. So for that, various process like painting, wiling, greasing, galvanizing is very important process. Chrome plating, anodizing, and making alloys. So many alloys are available. Okay. So what is the galvanization process? So it is used for the steel and iron where coating of the zinc is applied here. Sometimes maybe you'll get the question, even coating of the zinc is broken, still this iron doesn't have rust formation. Now since why zinc is more reactive than iron. So finally this zinc itself will form the zinc oxide. So iron is still protected, even layer is broken. Next is the process by alloying. Alloying means you are improving the impurities of the metals. Two, three metals or one metal, non-metals are mixed together. So that is the homogeneous mixtures to form the alloy. Like here, in case of iron, if you mix the 0.5% of the carbon, its hardness is going to increase and will become the strong. So like we have a stainless steel, it is the alloy of iron, nickel, and chromium. And we have gold here. So you know that in the market, 24 karat gold is not used to make the jewelry. So it is allied with some percentage of silver or copper. So 22 karat gold is used to make the jewelry. And amalgam. Amalgam is the alloy of the mercury, like cinnabar or cinnabar is the ore of the mercury. So this amalgam is very important. If in the alloy, if one of the component is the mercury, so in that alloy will call as the amalgam. Okay. Whatever percentage of mercury, but one of the component of mercury is there in that alloy, then that alloy will call as the amalgam. Another alloy is the brass. It having copper and zinc, which is not good conductors. Copper is separately good conductor, but when you make the alloy, okay, it's not the good conductor, means it's going to lose the properties. Okay, so alloy will have some different properties what was not there in the constituent materials. Like again bronze, copper and tin. So copper again good conductor, but this bronze is not good conductor. Soldering guns, soldering wires, whatever we are going to use there, it is made up of PV and SN. So now if you see that it has low melting points, but separately if you see that lead and tin, it doesn't have low melting point, it has high melting point, but due to alloy formation, this melting point is reduced. So like this, we have discussion about metal and non-metals and how it is going to react. Okay. So please go through this, like, subscribe, share with your friends, write your comments, whatever your requirement is there, I will try to fulfill. Thank you.